Hi, welcome to this Open Security Summit session in 2022 in March. And we have a really cool session for you here. So over to you.
Thanks so much, Denise. Hello and welcome to this presentation, everyone, from the Github Security Lab. My name is Joseph, and I've had my dream job here at Github for the past 4 months now. I say this because I'm very passionate about our mission, which is to inspire and enable the community to secure the open source software we all depend on. My part in that mission is to make security easy for developers, and this is why I'm here today, to use this 1 hour to give you the superpower of securing your code like NASA did. Well, this is not science fiction or a Netflix scenario. 10 years ago, when NASA's Curiosity was landing on the surface of Mars, NASA engineers performed a code review mid-flight. They wanted to check the software responsible for opening the parachute of the Curiosity rover during landing on the surface of Mars. And that was when they found the bug. The snippet on the slide that is written in C is not the actual code, but a fair description of what was really happening. The little bug that the NASA engineers discovered was that the function signature in line 1 expects an array of 12 elements, but an array of 3 elements will be passed as an argument in line 8. This means that the loop in lines 2 and 3 would read the correct memory coordinates just for the first 3 elements, but then it will go out of bounds, leading to random behavior. The NASA team found out that this case could prevent the parachute from opening during the landing phase and lead to the crash of the Curiosity rover. The smart thing that NASA engineers did was that they didn't just fix that vulnerable instance, but they wrote a generic Codecl query to look for variants of that vulnerability in all their code bases. What we call a variant is another occurrence of the same bug pattern at another place in the code base. And they found 30 other of those variants. They analyzed that some of those would also result in catastrophic consequences, such as the crash of the rover. They fixed all of the variants, and Curiosity was able to land safely on the surface of Mars. If we now see the bigger picture here and compare the scenario of fixing a bug mid-flight to that of fixing a bug in production, then I'm sure you will agree that it is very late in the process of software development lifecycle. Last year, NASA sent another rover to Mars. It's exactly 1 year ago, but what have they done differently this time? They shifted security left by integrating Codecl at the very beginning of their software development lifecycle by using GitHub. In 2 clicks, you can enable code scanning with Codecl yourselves and get alerted about security vulnerabilities in your code. Codecl is free for open source, and you can benefit from the continuously growing query set contributed by us, GitHub, by the community, and by top security team like NASA's. That's already nice, as you can consume the world's security knowledge to secure your code. But in today's presentation, I will show you how you can not only consume, but also be an actor in your use of Codecl. Let's introduce security as code through the lessons learned from DevOps and quality assurance. One of the main levers of DevOps adoption was the introduction of infrastructure as code, where developers use code for setting up their own infra without the need to open tickets to operations teams. The fact that developers were writing code empowered them with further benefits, such as reading, contributing, and understanding what they were doing. Same for the world of testing. In the pre-agile days, developers and testers belonged to 2 separate teams. QA will find the bugs and report them back to devs. Nowadays, this methodology will not resonate with the vast majority of developers as they progressed in taking ownership of the automation around code testing. So we believe that what worked for testing and operations should inspire us for security. With security as code, we expect the security experts of an organization to codify security knowledge that is then shared under both readable and executable form with developers. This sharing helps developers read, understand, and contribute to the code, which facilitates a security culture. Therefore, think about security becoming a seamless, automated observer of the day-to-day DevOps that doesn't intervene or affect the speed of DevOps. Security as code will be integrated and automated to the pipelines so that every time a security-related violation exists, actionable feedback will be generated. By the way, you hear more and more people talking about DevSecOps nowadays. The vulnerability covered by our demo is a SQL injection or Sql injection. And I just want to introduce it here for those that are not familiar with it. As per the meme on screen, this happens when a user is able to execute arbitrary queries on a database using SQL. The root cause of this bug is insufficient or missing input sanitization, allowing users to execute whatever database operation they want. The backend of the software on the meme will be similar to this. The text in purple represents the user input, which is processed and sanitized. The query at the top of the slide inserts the name Clio into the database. But the second example shows that by passing user input that contains the parentheses and semicolon, a user is able to trick the backend into creating a second query that deletes the students table once and forever. While the third line with the two dashes is gonna comment out anything that the backend code will add after the user input. This is a very simple example, but in real life, user input flows in different places of your code base through files, functions, before reaching the SQL execution. In our demo, we will build a query that automatically finds SQL injections in those complex scenarios. Just before the demo, let's define two important concepts for our data flow query: sources and sinks. Sources are places in the program that receive untrusted user input. For example, a field in a web form is the source of the vulnerability. Sinks are places in the program where something malicious can happen if the malicious input reaches these places. In our example, the sink is the place where the SQL query is executed. The question we need to ask is a data flow one. Does this untrusted data ever flow from the source to the sink so that it's being executing in a vulnerable way? We can answer this question by identifying all paths from sources to sinks by using Codecl. Notice that Codecl allows users to query code in general, not necessarily for vulnerabilities. You can use it for any type of bugs or just explore your code. We try to make these queries generic to find variants of vulnerabilities like NASA. And the biggest benefit you get is that you will now be able to codify your knowledge of a whole pattern in an expressive query language. Codecl as a language is declarative and logical. Declarative means that we describe what to find and not how to find it. Logical means that you will use operators like and or to define conditions about your domain. Codecl is object-oriented, taking advantage of features such as encapsulation and inheritance composition. However, as a total beginner myself a few weeks ago, the feature I appreciated and found the most useful to get started with was the existence of a rich set of standard libraries with reusable logic that made it quicker for me to be productive. For example, there are templates to use, like the one of data flow analysis that we are going to see in our demo. Finally, our demo is designed for total beginners. And while our examples are in Java, you don't need extensive experience with Java either, as what I will show you will be transferable to other languages such as Python, JavaScript, Go, Rust, C, C++, and C# that are supported by Codecl. Now, let's switch to our demo. A note here is that I'm going to monitor the chat for the questions at the end of the session. We have plenty of time, just 10 minutes remaining here. And I'm just going to start from the top, finish to the end, and give you all the rest of the time to ask questions and discuss about anything. So, to the demo now. Let's first check our vulnerable code base, which is the intentionally vulnerable security shepherd from OWASP. We have a SQL injection vulnerability in a mobile app. The source is in line 98 and 99, where the program receives a username and a password for user authentication. This is because there's no sanitization happening with the username and password variables being used to query a database at line 147 here, where the first parameter of the raw query method, namely query, is the sink. So you have the source is being the username and the password, while the sink, where the username and password are actually being executed as SQL, is on line 147. Now, let's write a bit of Codecl to understand how we can do security as code in the same way like NASA and so many other organizations and open source projects in our world. If you're familiar with Codecl, if you're familiar with SQL, the structure of Codecl may look familiar. We have the import clause at the top that allows us to reuse logic defined in other libraries. In this example, the Java standard library. Then we have the query clause that describes what we are trying to find. It is made up of 3 parts, normally the from, where, and select. Let's first learn about 2 of them, the from and select, before adding the where in a moment. The from specifies the variables that are going to be used in the query. Every declaration in the from clause has a variable type and a variable name, while select specifies what the result should be by referring to the variables above. As per our Sql injection explanation, we need to arrive at those methods that receive user input. How do we do this? We first need to start by getting all the methods in the program, and then we are going to filter only those that receive user input. In the Codecl Java library, to find method invocations, we can use the type method access, which is here. And then we can use a variable that here I name it call. And then we can return the call variable. So if I run this, it's going to give me all method invocations in the program. So the intentionally vulnerable security shepherd from a WASP is having all these methods here. So if I click in one of those, like generate key, this is where it occurs. If we continue here, the point is to filter and have only those methods that are receiving user input, which is going to be our source of vulnerability. To achieve this, we need to impose some restrictions on the variables. So I can use the where clause and some logical conditions in order to reduce my set down to those methods that only receive user input. So let's use the where clause here. And I'm going to use a method that is called get method that is expected to give me all the methods in the program. So I can impose some further restrictions, like, for example, ask for a specific name for that method. In order to search for the specific method, look how I'm making use of the auto-completion and how the inline dog is helping me with what is expected from me as I complete the code. Inside the where clause, we can also see the object-oriented nature of Codecl because get method is an operation provided by the type method access, which through chaining provides further options, for example, to look for a function with a specific name. And this is another feature that Codecl brings on top of SQL, which is expressivity with chaining. We can see from the signature of has qualified name that it is expecting a package name, which here is android.widget. I'm getting this from the code I've shown you before. The type of the methods I'm looking is one of those that receive user input, and the specific name of the method that receives user input is getText. So if I run this, I expect to find all invocations of getText in the code that are potentially vulnerable to SQL injection because they receive untrusted user input. Let's see how many of those are indeed vulnerable. Now, let's proceed to sinks. We can use the same strategy with the difference being that we are looking for a different method in a different package name. So I've shown you before that the sink in here is raw query, line 147. And specifically is raw query when the first argument is being set, because you actually have the source being actually executed. Otherwise, if you just receive untrusted user input that is never executed, it's not a real vulnerability. It's just a possibility that when it's going to be executed is actually a vulnerability. So as we saw, raw query takes two arguments, from which the first is the sync. Let's further refine our query by only asking for the first arguments to be returned. We can do this by using the type expression alongside a new variable. I will call it arg. It's being underlined because I didn't use it so far. And we can impose further restrictions. So I want you to find me the raw query methods where there's a first argument being set. To do this, I can use the get argument. And you can see here the auto completion saying that gets the argument at the specified position in this method access starting from 0. Indeed, we are looking for index equal to 0. And we need to return this as well, the argument. So if I run this, I expect to find the invocations of raw query that are having the first argument being set. Now let's see the real power of Codecl. So we defined our sources, we defined our sinks. Let's now move to the data flow functionality, which is what is going to provide us with confirmed SQL findings, SQL injection findings. Luckily, the language comes with a rich set of standard libraries that have ready-made templates for us that we just have to fill. On top of the file, we see some metadata here in lines 1 up to 5 that are helping Codecl understand what we are trying to do. Ignore them for now. We then imported the taint tracking library, which is a template configuration in line 7, 8, 9. To track untrusted user input, followed by the data flow path graph library, which is all about the visualization of results at the end. We are defining a class in line 11, which extends the taint tracking configuration, again, to help us out, as the taint tracking configuration is a boilerplate. This is actually an example of how users can benefit from extensibility, and through classes, the expressiveness of a language is highlighted. Another important feature on top of SQL is code reusability through predicates. Predicates, as you can see in line 14 and 18, is a way to reuse logic. It's like functions. Predicates provide a way to encapsulate portions of logic in a program so that they can be reused. What's important is how we are going to define the isSource predicate and the isSync predicate. We just have to override them using the code that we have already written from before. Just before filling in the predicates, let's briefly talk about the idea of data flow being represented by a graph with nodes, so that when there's a flow from one node to another node, then these two nodes are connected. I'm saying this because the two methods here, namely isSource and isSync, are getting a variable of type node as input. In the parentheses here, line 14 and line 18. We can now fill the predicates by using the exists keyword. And I'll tell you just in a moment how it reads by using the code from before. So remember that the source is about the method that accepted untrusted user input. So there exists a method such that when this method is the get text from before, we know that untrusted user input is getting into our program. So I can use the code from here, really. Copy and paste. And I'm going to change it to be when you have call get method and the node. The source node is actually the one that is the get text. Then you know that you have confirmed code untrusted user input getting into the code base. We can do the same for the sync using the same tactic again. So remember from before, there exists a method call that is named raw query, such that when this raw query is having the first argument being set, it means that you have an Sql injection attack because the untrusted user input has been executed. So there exists a method access such that, and let's use the same code from before. Should be node as expression, because we are speaking about the sync node, which is going to be the one expecting to have the raw query first argument, really. So if we run this, we are expected to have flow from sources to sinks and confirmed SQL injection findings, like we can see on the right. Let's analyze this now. If we click on the first finding of SQL injection, you see that you have two paths from sources to sinks. Let's break down the first path. That is starting from the username being accepted in the code base, is then flowing into the login where you have the check name and the check password. Here we need the check name because we are speaking about the username, and then flows in the signature of the login method before being executed as an SQL query here. Another pathway that this untrusted data can end up on the raw query method is the one that I just expanded. So you have the same source here being the username accepted in our code base, but here notice the difference between the lines 102 and 116. So the two things that I have highlighted. You have the first code on line 102 having a Boolean equation on whether both username and passwords are being set. And then you have the other one being on the false. So you have a different pathway that is again going through the login method to end up on the raw query. So two different pathways, same vulnerability. And now we have another instance of an SQL injection, again with two pathways, starting from the password, flowing in the check pass like before, login method, and then the query. And the other path is exactly the same, with the difference that here you check, again, line 102, line 116, the two different ways that the login can go. But the idea here is that you have two different pathways leading to a vulnerability. So if you think of the big picture here, sometimes the path from a user input to the real SQL injection can be very long, with more than 10 steps across several files. Imagine how difficult it will be to find those manually. Let Codecl do it for you. So I created a query for me to find all these vulnerabilities from sources to sinks, no matter where they flow from. Finally, you can start your Codecl journey by visiting the following URLs that are also shared with you in the description of this stream. I mean, we can share it with you afterwards alongside the slides and everything. And here we are. Thanks so much for having me. And I'm now going to answer questions. Thanks, Open Security Summit. Shall I stop sharing here? Yeah. I don't see any questions, which either means you didn't understand something or you understood everything, which is amazing. I'm here for you. We have all the time of the world to answer questions. If something was not clear in my presentation, we can chat about anything really, all things about security, what my team is doing, what GitHub is doing, about Codecl, or in general, the stage is yours. Let me know what you think about Codecl, if you think it has a potential to help you, help your code. Thanks so much, Fraser. So a question I'm getting a lot, and it's a hard one to answer. It's that, for example, let's take your code. Okay, I'm gonna cover what can be done with the output. Let's cover this first. So the output is really a set of alerts that are coming to you specifying where you have a problem, like that's the source, that's the sink, that's the flow, the same thing like I've shown you, having the pathway. So you can use this output and fix your code, commit again, push again, and see if you are getting the same alert. So the real benefit is that if you make this mistake in a part of the code base that is like, I don't know, 1% of your code base, 0.01 of your code base, people tend to code in the same way. I'm one of those. So maybe I made this mistake or a similar mistake somewhere else in my code base. You can pick up this mistake automatically in the same way like NASA did, in the same way like my demo did, and save you from all that manual things that you will do. Otherwise, imagine every time that you add code to need to like go through the same thing manually. Codecl is automated, doesn't need like effort really. For me, it was 2 minutes to turn it on, and take care of everything for you. So a question I'm getting a lot is that, what if I change the get text method now in your demo so that you don't have that being the source of the vulnerability? Yeah, that's true. You need to adopt your Codecl queries accordingly so that a vulnerability is actually being picked up. However, if we think about the big picture, Java as a language is such a huge advocate of backtracking or backward compatibility. They will never, ever change any method name or anything. So I challenge you to run Java from 20 years ago using anything. So this means that these times that you need to adopt your code are minimal. Like, I don't know, they are never gonna take you as much time as you think. And it's gonna happen only if you have tailored code. Because the idea here is that Github Security Lab and other teams like NASA's Mercado Libre, for example, and so many other companies, security researchers, bug bounty hunters, etc., when they contribute Codecl queries, they are focusing on open source. So when you import open source libraries and you use like languages that really care about backward compatibility, the times that you need to change your code is like, for me, should be considered like nothing. Plus the fact that there's object-oriented nature and inheritance composition make you able to make all the methods specific, pointing to the method above. Like, for example, instead of me using getText specifically, I could do something along the lines of, when something is of the nature of accepting something, then act as a source. A question here is a couple of questions. Are you able to trace data flows over? Are you able to trace data flows over multiple functions? Yes, over multiple functions, over multiple files in the code base. Not just, you are not restricted in one file, you are not restricted in one function. We could have a data flow here being from this file to that file to that file, because that's how real code bases look like. They are complex. You have code flowing from one code base to the other code base. You have blind Sql injection attacks or stored attacks with code residing somewhere and being executed from somewhere else. Yes, so you can trace the flow all over.
So that was my question. So can I expand on that? So how does it do it? So do you create does Codeflow now create an object model?
Yeah, so the way Codecl works behind the scenes is by creating an abstract tree, an AST.
Yep.
So for me, I'm not a software developer on that, but I've seen the idea, which is you need to import your code base in the form of a Codecl database. The VS Code extension does everything for you. You just need to point your your Codecl extension installed in VS Code to the database of your code that Codecl is going to create for you. And that database behind the scenes is representations in the form of an abstract syntax tree of how often you use a function, where you use it, how are your functions connected.
Do you have access to that AST?
I'm sure you can see it or something like that by double clicking in the database, but I don't suggest to do it manually, because you can have automation helping you.
Yeah, no, but programmatically, right? I'm saying to write more advanced rules, right? You know, that's
to write more advanced rules. Yeah. You can instead of being a passive consumer of Codecl, like someone who's just gonna turn the Codecl extension on in GitHub Actions for them and consume our queries, you can tailor some of the templates and some of the queries that are already out there, already public for you. And you can make them very tailored to your private code base, like some enterprises out there do, to help them automate security and ship code that is secure.
Cool. And then how do you deal with abstraction, for example, abstract methods, right? Or interfaces where the connection between one part of the code and the other part of the code only happens at runtime?
So it's a good question. My understanding is that you are gonna, so when the database is created for you, they create this type of object-oriented stuff that you know that this specific function, this specific class, this specific variable is inheriting something from the class above. So you can actually impose restrictions or query something of a type, something of a nature, which was what I've done in the source query. I've specified the getText method because I wanted to have the flow from getText to raw query, but you could just do any function that is inheriting from the interface that is responsible to accept input, which contextually was edit text in Java code there.
Yeah, but that's the challenge there, is that sometimes those wires only happen dynamically. So Java is very common on that. So there's a lot of wiring that only happens through the Spring config, for example, or the files. And if you have things like Python or JavaScript, that's even dynamic, right? So it's almost like you actually you almost need to run the code, right? You know, and that's one of the challenges of static analysis.
So it does run the code. It does take like 30 seconds to come back with results to you. I mean, I don't know the exact benchmarks when it comes to time, but you do need to wait for like a few seconds. For me, it was fast because everything was cached and my code is like very small here. But again, like if you think about the times that it's gonna take you to perform manual code reviews or do everything in code bases that 10Ks of lines or millions, Codecl is gonna be much faster for you. At the same time, Python and JavaScript, yes, they work differently. So Codecl has a complete different approach to those. To the user, it's the same thing, but you have some keywords being changed in the language, but the way you run the code, the way you perform and you use the templates is the same for every language. Behind the scenes is not the same for every language. And if there are specific questions about that, I'm more than happy to speak with like the product managers and the software developers working on that and come back with an answer in a tweet, or I can message you.
Yeah, that'll be cool. No, because I did some really crazy stuff many years ago on static analysis. I'm just curious. If there are any other questions, I'll gladly ask a couple more, because I think it's definitely a topic that I'm very passionate about. You can add custom sources and sinks? Yeah.
So the code is in your hands. You can do whatever you like with it. Consider like a different application that is not open source. It's in your code, it's in your home, in your company. Yeah. Your source and the sink are not going to be the same like the one I've used. So you can edit the code and do something that is gonna find sources and sinks for you.
Yeah.
The point is not sources and sinks. The point is to come up with confirmed Sql injection cases. And for every vulnerability out there, there are Codecl queries already existing. So nobody's really writing from scratch, in my opinion, anymore. People are starting like from code that is already there, and they are adding something more tailored.
Yeah. So Nuno is here. I don't know if you can speak, but Nuno, I just made you a co-host. But Nuno runs a really cool startup that they do basically the automating dynamic analysis. And one of the areas that I still feel that we don't do a good job is the dance between both sides, because the dynamic analysis, they work in reality. They crawl the sites, they actually can prove that this is exploitable, and they do a lot of work to clean the false positives. The problem is they don't see sometimes what's behind the scenes. In the static analysis, sometimes we see a lot of stuff, but we don't have the evidence. Is this exploitable? Is this a real problem, or is this just something that exists on this side of the code base that actually it doesn't really matter because it's not really that exploitable? So have you done any work or any kind of thinking about how do you connect both worlds? How can you consume the data that the dynamic tools can create, and how can you feed data into the dynamic tools?
So to be honest with you, as I'm not involved in the development side of that, I'm not aware of any conversations or thoughts of becoming like one for all, having SAST and DAST at the same time. My opinion as a security professional is that you definitely need the best of the two worlds, or even three worlds if you think about like other forms of testing. Codecl is static analysis, is not dynamic analysis. You definitely need dynamic analysis as well. And when you come up with the results of Codecl, yes, you do have confirmed cases in my demo of Sql injection, for example, but it's up to you if you are going to fix it, how you are going to fix it, how much is the risk there, and so on. If you think about the idea I've shown you about sources and sinks, consider just sources without sinks. It's not a vulnerability really. There exists the potential of becoming one, but is not one. So the dynamic analysis will show, if I was cutting my demo at half, that you don't really have something exploitable there, but it can become exploitable in the next 5 lines of code when you do something else.
Yeah, no, I'm not sure if Nuno is able to chip in. So I'm going to name drop another one. Fraser, since yesterday. What about the integration between static analysis and this technology with things like threat modeling? Because again, right, if you think about it, the threat modeling, we need to map reality, right? And here you go. Here's an object model of reality. And also threat modeling sometimes gives you the connections between this component and that component and that component.
Well, so I'm talking about Open Threat Model Standard tomorrow, and what that does is it represents a threat model in a vendor agnostic way. It's a YAML file specification that says here's components, here's trust zones, here's data flows, and things like that. If you can get something like CloudFormation or Terraform or code, and you can pass it and say, right, this is how I would map this thing to a component in a threat model, then the Open Threat Model Standard can sort of represent that. One thing I did a couple of weeks ago was, so I use VS Code for hacking around, and there's a bookmarks extension that allows you to go and bookmark bits of your code. And what I did was, you can create labeled bookmarks that gives it a pretty name, and I use some convention like OTM : user profile for a piece of code that represented a user profile in a web application or something like that. And then the VS Code extension will write that to a JSON file, which you can then pass and generate, a component in a threat model represented for user profiles. And then you can start to build out this picture. The reason why I got very excited and put that message on the chat was, this sounds like a very powerful way of being able to say, when I'm looking at a threat model, when I want to build a threat model, here's the kind of thing I'm looking for in my code. It talks to a database and it has the word customer in the name and it does something else. That represents a component in a threat model, and you could sort of build up a library of these queries that map to the components that you have in your predetermined sort of set of components in a threat model. Amazing, very cool idea.
It's an amazing point, and a really good like planning with a structural way of how to do things.
Yeah.
Good news is that you don't really need to like take the queries and import them somewhere and have a specific subset of queries being run for you. All the queries that ever entered Codecl are gonna run for you automatically, no matter if they are not applicable in your code. As in, if you don't have a database, it's gonna be matched based on the language you are using.
Yeah.
So if your code is Java, all Java Codecl queries are gonna run for you. But 100%, you need a methodology of, that's where I think my risk lies based on a sound threat model approach. That's my mitigation through this tool and that tool and this approach so that I can do that. I just realized that I can't really see the questions. I'm just in a very small chat where we have Fraser and Denise. If there are other questions, drop them where Denise just said. How's it going so far? I'm planning to attend some sessions, like end of the week mostly, the roundtables and so on. Are you happy? Is it exciting?
Yeah, no, this is and these kind of questions and this sort of interaction is exactly what it's supposed to be about, right? It's about getting multiple people with multiple disciplines, connecting the dots, right, and figuring out the best way to collaborate. That's the summit in an essence, right?
And based on that, I just want to say a bit about GitHub Security Lab specifically. I'm not here to sell you Codecl. I'm here just to inspire you in securing your code for open source in general. So our mission is to secure the open source code that we all depend on. So our team is trying to educate open source developers on security best practices on everything. Codecl is just a part of it. Personally, I have my own series in YouTube. It's called Security Bites. I can drop the name here, where I speak in 3 or 4 minutes about a security vulnerability. For example, I speak on the behalf of the developer. I'm trying to show the developer what nobody is showing really. I mean, it's very common in YouTube to see how someone can exploit an Sql injection or XSS, CSRF, weak encryption, you name it. But when I show you code and you see the actual mistakes and how you can avoid it and understand the root cause of the problems, for me, that's a win-win for everybody in the open source community. How do you compare Codecl with tools like Sneak or SonarQube sort of tools? Yeah, so I never personally want to go and perform product or competition analyses or tool analyses or market analyses and things like that. My take is for you to use and find out for yourselves, and you can define your own metrics of comparison, like for example, false positives or the languages that are covered, and find out what works best for you. I'm not trying to be politically correct or diplomatic here. It's just my way. I will never speak bad or something. I truly believe that it depends on the case. There's no one tool for all. Maybe another company is doing something better in a specific way, another something else. I totally believe that we are doing really good work in finding vulnerabilities because you have the incentives to find them. Like, for example, the open source community is working with us to contribute Codecl queries, and everybody's helping everybody in this indirect way. Of course, our mission is about open source. So it's not about the tools, it's about the mission and how we go there.
Very, very cool.
I was wondering, for example, if you suddenly get dropped a big old code base, would it be possible to use Codecl to analyze it in a more general way? Given only a source, identify the possible things and vulnerabilities, or you need to always define both ends? Yeah, so good news is that you don't need to define anything. So for example, for me, I've written Codecl. I see two things for you to do. The first one is that you are a passive user. You just drop this old code base and you let Codecl find vulnerabilities for you. My guess is that if the code base is old, you are gonna get Codecl results that correspond to old CVs, because the idea is to have like Codecl queries that are matching CVs. If you now want to do what I've done, which is to write code yourself, tailor the code base, and so on. So your question is to analyze in a more general way, given only a source, identify the possible things. Yeah, okay. So for me, the way I will do it is that if you think about my demo, I will not define the source, the thing at all. I will keep it on sources. And then I will run the final bit, the data flow thing I've shown you, with just the sources. You are going to have the exact same results in the specific code base I've shown you, because we have the username and the password. But in another code base that you are using something else that's flowing all over the place, and you just want to follow the source around without defining a specific thing, is totally doable. Remember what I've told you during the presentation? Codecl is not only to find bugs. You can search your code with Codecl. You can query your code with Codecl. I mean, I don't want to go to specific name-specific places here, but I just want to give you an example. So in 2018, I was doing some work with cryptocurrencies, and I was reading code bases forever. I've read the code of a very known cryptocurrency, like a top 5 one. I know the code base in detail. So I was using command find all the time to go from this place to that place and blah, blah, blah. When I started my Codecl journey a few weeks ago, I was like thinking all the time, imagine if I had that 3 or 4 years ago. I will spend a bit of overhead in the beginning to learn how I query my code base and so on. My goal was not cybersecurity. And then I will just like, it's gonna make my life so much easier. So some queries here, some questions here. How effective Codecl for scanning software, component analysis, SCA scanning, like detecting vulnerabilities in important libraries, etc. Yeah. How old is Codecl? Okay, so to be honest, I don't have I'm not sure about the answer here in both questions. How effective Codecl for scanning software components analysis, scanning like detecting vulnerabilities in important libraries, like supply chain, right? Like for example, I've imported this library and I'm using this library now in my code. Brijesh, is that what you mean? Like for supply chain risk and attacks? Yes, okay, cool. So without being 100% sure, and again, I'm more than happy to speak with people that are like years in that journey, and I can tweet about it and tag Open Security Summit and give you like the exact answer. The reason that I'm not sure about it is because I've seen products used by people I know that are specifically to target supply chains. So that's why I'm a bit afraid to give you a definite answer for Codecl. My guess is that you import a library and you plan to use this library in your code. So if you are using it in a way that you introduce vulnerabilities, definitely it's gonna be picked up. But if the imported library is vulnerable, I need to come back to you if Codecl is gonna pick it up. I don't think so though, because the library comes in the code base, but the AST might not have it in full. So I'll come back to you with that. And then how old is Codecl? So the journey here, without knowing the exact number, is that Codecl was created, I think, I don't want to give the exact number. It's from a company that it used to be named Semmle, S-E-M-M-L-E, based in Oxford, here in UK. I'm based in London, by the way, that's why I said here. So this company was bought by GitHub in 2017-ish, and then GitHub was bought by Microsoft in 2018. So you have this acquisition and then another acquisition. So effectively you have the SaaS engine of Codecl being Codecl through an acquisition. And I think that Codecl was like 3 or 4 years old before the acquisition. So without giving the exact number, I think maybe 7 or 8 years old.
All right, cool, thanks.
And is there any existing security unit test cases correspond to OWASP ASVS? What is it, ASVS? So I can tell you for sure that OWASP is like very well covered from Codecl, AppSec verification standard. I'm not familiar. Maybe it's embarrassing that I'm not familiar, but can you tell me a bit more? Can you tell me a bit more, please? Like, you mean for authenticating, if there's like a vulnerability there, if it's gonna be picked up? It's on a OWASP project.
It's a set of different controls that you need to do it at different sort of maturity levels in order to be, have a good application security program and secure code, etc.
Yeah, it's predefined set of security controls and the standards defined as part of this project. So you can actually download that. So there are multiple standards: standard 1, standard 2, standard 3. So the corresponding to each of the standard, you have a set of security controls defined in that under that. So you can actually simply download that and see that that's applicable for your code. So in fact, why I asked this question is because there's another tool similar to this, like SendGraph. So they do have the corresponding the rules defined, out of the box rules defined for each of the security controls defined in the OWASP ASVS. So that's the reason I just asked, because we are in the process of actually analyzing a various unit test cases framework, security unit test cases framework.
Perfect. Thanks so much for the introduction there. Definitely sounds like really helpful and much needed. Yeah. My guess here, because I'm not aware about the specific case, is that it's not a compliance tool. It's not going to tell you if this control is there, that control is there, that control is there. It's going to alert you if you have a vulnerability in your code that might or might not be happening because you omit some controls and so on. I think that's my answer there.
Yeah, so definitely if there is any out-of-box, the rules or unit test cases defined already, it is easy to adopt that, easy to import and use in our code. If you are actually using, if someone, if in your project, if you're actually using ASVS controls, it's easy to download the Codecl test cases and make use of.
Yeah, definitely. I mean, in the same way you could do NIST or like something else, but the idea is that these controls exist because some CVs existed and exploited those vulnerabilities. So Codecl queries exist to match these CVs. So it's, I mean, more or less we arrive in the same conclusion in an indirect way. So I would like to thank you again for having me, Open Security Summit, Denis and team.
Thank you so much, Joseph. If there are not additional questions, the session, I'm going to stop the recording.
Yeah.